In this video, we'll be looking at the standard form of a quadratic function. This is sometimes referred to as the vertex form. So if you see either of those, they mean the same thing, and this is what we're referring to. So standard form or vertex form is this guy right here. So A times x minus h quantity squared plus k. So this is very reminiscent of how we saw parabolas when we did transformations of functions. So think of this as our transformations, and we're moving our graph h units horizontally and k units vertically. So this is going to put our vertex at the point h and k, and our axis of symmetry will be the vertical line at x equals h, again going straight through that vertex. And then just like we saw before, if a is positive, our parabola opens up. If a is negative, that would be an x-axis reflection, so our parabola opens down. All right, so let's go ahead and look at an example of graphing one of these. All right, so to start with, let's find our vertex. Okay, now for these, it's easiest just to think about your transformations. So we saw way back at the beginning of this section that your standard parabola, your parent function, has its vertex at 0, 0. So that's our starting point. Now here, if we think about our transformations, this is taking our graph 3 units to the left and 16 units down. So that 0, 0 point would be transformed to -3, -16. All right, the axis of symmetry then goes straight through the vertex. That's just the vertical line x equals -3. Okay. Our a value on this one is just the understood 1 that's out front. So since that's positive, our parabola opens up. All right, so then just like we did when we graphed our parabolas in general form, we need to find our x and y intercepts. So let's go ahead and find our x-intercepts here. So plug in 0 for y. So we have 0 is equal to x plus 3 quantity squared minus 16. All right, now the easiest way to solve a problem like this is to isolate the square first. So meaning add the 16 over. And then square root both sides. All right, and remember, anytime you take a square root, it comes with a plus or minus. So this would give us plus or minus 4 is equal to x plus 3. And then just subtract that 3 over, so we would get x equals -3 plus or minus 4. All right, so then if we think about these, -3 plus the 4 would give us a positive 1, and -3 minus 4 would give us a -7. So our x-intercepts are going to be at 1, 0 and -7, 0. All right, then the y-intercept, we don't have a shortcut that we can take when our equation's in vertex form because we don't know what our c value is. So we have to go through the whole process of plugging in 0 for x and solving it out. So if we're looking at our function right there, so we have 0 plus 3 quantity squared minus 16, so plugging the 0 in for x, and then just solve that. So it would be 9 minus 16, which would be a -7. So our y-intercept is at 0, -7. All right, then just graph all of this. So notice on this one, my y-axis is counting by 4s and my x-axis is counting by 1s. All right, I just counted by whatever I needed to fit my points on my graph. Doesn't really matter what you choose, as long as it's consistent and it fits. All right, so my vertex is at the point -3, -16. I have my axis of symmetry passing through that vertex at x equals -3. All right, and then we have our x-intercepts at -7, 0, and 1, 0. And our y-intercept was at 0, -7, somewhere right in there. And then again, we can use symmetry to mirror this point over to get an additional point on the left-hand side. So this y-intercept is 3 units to the right of our axis of symmetry. So if we go 3 units to the left, we'll get an additional point here at -6, -7. And just plot that point. Right, and then just connect all your points, and we'll have our parabola. Beautiful. All right, and lastly, find our domain and range. Okay, so domain for every parabola is all real numbers, and the range is just from the bottom up. So that's going to be from -16 to infinity. All right, the next thing we're going to look at is changing an equation from general form to standard form. And essentially all we need to do in order to make this change is to find the vertex of the parabola, because our standard form is also known as our vertex form. So if we can find the vertex, we can easily write our equation. So let's go ahead and look at A here. And let's start by finding our vertex. Okay. So vertex, when we have an equation in general form, or we just use the -b over 2a. So in this case, -12 over 2 times 2. So that would come out to a +3. The y-coordinate of the vertex we get by just plugging the 3 back in. So 2 times 3 squared minus 12 times 3 plus 9 would give us -9. All right, so that puts our vertex then at the point 3, -9. So that is our H and K. Now the nice thing about this transition from general form to standard form is that the A value is the same in both. So here our A value is equal to 2. That's going to be the same A for our standard form. All right, so standard form, remember, we saw up above here, right back up here, is A times x minus h quantity squared plus k. All right, so if we just plug our pieces in here, our A value is 2, our H was 3, so x minus 3 quantity squared, and our K is -9, so minus 9. And that is our final answer. Okay, I'm going to leave B for you guys to try on your own. The answers are up on Blackboard. All right, another thing we can do is to take information and put it together to build an equation. All right, so example 5 here, we're given the vertex of a parabola is at the point 5, 4, and we have another point on the parabola is at -2, 151. So our goal is going to be to write the equation of this parabola in standard form or vertex form, which is again our f of x is equal to a times x minus h quantity squared plus k. All right, so the 5, 4 right here, that's our vertex, so that's our h and k on this one. So right off the bat, we can plug that in. we'd have x minus 5 quantity squared plus 4. All right, now to find the a value, we're going to have to do a little bit of extra work. And that's where this extra point comes in. So to find the a value, we just plug in the -2, 151 for our x and y. So for y, we plug in 151. A is still unknown. And for x, we plug in the -2. And then we just need to solve for a. All right, so our -2 minus 5 is a -7. Squared would give us a positive 49. That's 49a plus 4 on the right-hand side. Subtract the 4 over, which would give us a 147. It's equal to 49a. And then divide by 49, and we would get a is equal to 3. All right, so putting this all back together, we get f of x is equal to 3 times x minus 5 quantity squared plus 4. All right, so that is our final answer. All right, example 6, I'm going to leave for you guys to try on your own. Let's go down here to example 7. So this is the same kind of idea, it's just that now we're reading the information from a graph instead of being given it explicitly. So if we look at this graph, we can see that we're given two things. We have our vertex point down here, and if you read that, it looks like it's a 4, 6. And then we have an additional point right here. It happens to be our y-intercept, but it doesn't have to be. And that one is at 0, 14. All right, and now we're just going to do the same thing that we did in example 5. So we're trying to find the equation of this parabola, and it's always easier to find the equation in our standard form or our vertex form. I always recommend that you go that route if you're asked to find an equation. All right, the vertex, remember, is our h and k, so we can start by just plugging that in. That would give us f of x is equal to a times x minus 4 quantity squared plus 6. All right, then we can use the point to solve for a. So plug in 14 for y, and plug in 0 for x, and then we'll just solve it out for a. That would give us 14 is equal to, this guy would become a 16, so 16a plus 6. Subtract the 6 over, so 8 is equal to 16a. Divide by the 16, and that gives us a is 1/2. All right, so then putting it all back together, f of x is equal to 1/2 times x minus 4 quantity squared plus 6. All right, so that is it for our quadratic functions. So the next section, we're going to be looking at applications of these quadratic equations. So look forward to that in the future.